Example 4, graph each function, describe the domain and range of f. So, same idea, but if we take a look at this function has a lot more going on with it. We still have a, we still have b, and we still have an x power. But notice now our x power has a +2 on it, and notice that the whole function after we're said and done has a -1 on it. So I'm thinking that these two things are definitely going to affect what's happening with our graph, and at the moment, I'm not sure what it's affecting. So let's make a table, let's graph it, and then we'll talk. So, x, f of x, and the values I want you to use this time, we're going to use -5, -4, -3, -2, and -1. And that should give us a good idea of what this is going to look like. So remember, what we're doing here is we're taking the -5 and substituting it in for the x, so it's going to look like -2 times 3 to the -5 plus 2 power. Okay, the whole thing is in the power. And then when that's done, we're going to subtract 1. Take a minute, try to get that in your calculator correctly. But what we're going to get here is we're going to get -1.074. And we're just going to round that off at the thousands place, and that's absolutely fine. So -5 and then -1.074, so a little bit below the -1. We're going to do the same thing with the -4, so -2 times 3 to the -4 plus 2, and then -1. Which is going to give us -1.222. So -4, -1.2, just a little bit lower. Then we're going to substitute in -3. Which is -1.667. And then substitute in -2. You can pause the video, give that a try. But you should get -3. And then substitute in -1. And you should get -7, which takes us about right here. Now, if we're looking for this to fit that idea of an exponential function, it looks to me like we have it, but it's kind of been shifted a little bit. Okay, so if I've been shifted, we still have the 3, okay, and the 3, which is your b, is greater than 1. So this would still kind of fit like my growth-ish model, which remember makes it kind of go small and then big. But it really doesn't look like that. So then remember, well, then the negative here is going to reflect over the x-axis. So instead of kind of coming up like this, it's going to reflect and go down like that. Okay, well, that's what we're looking at here. That's what's happening, okay? It goes down like that. But it still is kind of like shifted left, right? Well, left how many? And this is where we start seeing these come into play. Okay, and more importantly, the first one I want to focus on is I want to focus on this -1 because that's the easier one to see. Where is the horizontal asymptote usually at? And it's usually at 0, right here, okay? But you notice this guy doesn't get right up next to 0. He gets right up next to a different number. He kind of comes up, gets close, 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 and he's getting really close to -1. So what a number on the end does is this is going to move your horizontal asymptote down 1. So now our horizontal asymptote is really going to be right here at -1. That's where it's going to get really, really close to and never touch. Now, a little bit harder to see. This one's easier to see. This one's a little bit harder to see. This actually moved our graph to the left too. So notice it's kind of shifted instead of like hitting right across the y-axis like we're used to seeing. It's kind of like sitting over here. That's a little harder to see, but that's why the graph is over here. But we're just going to graph it and make sure you don't hit -1. Then for our domain and range, it's not going to affect your domain. Your domain is still all real numbers. It still goes the whole way out to the left and the whole way out to the right. It's kind of hard seeing it go the whole way out to the right, but it does. But your range is what's going to get affected. Okay, so low to high. This one still goes the whole way down, but instead of coming up to 0 like it used to, now it's only going to come up to like the -1. So this is y is less than -1. Okay, example B. So first things first, let's maybe get a table here. X, f of x. This time the values I want you to use are -2, -1, 0, 1, 2. Okay, now before we do anything, I'm going to look at this and I'm going to go, okay, my b value, what's being raised to my power, is a fraction. So this is probably the one that goes more like down. So if I'm guessing, it's going down. Then my a value out here is positive, so it's not going to reflect over the x-axis. Okay, it's gonna stay above, so I'm guessing it's kind of up here. But then I don't see anything here that's going to like shift it left or right. But we just went over that something back here is probably going to move it up or down. And because I see a +3, my guess is that something's going to move up 3. So maybe instead of being here, I'm going to be more like I don't know, like maybe like up in here. So I'm going to erase all this. We're going to keep that in mind. And let's see what actually happens. So take a minute, 0.25. We're substituting into the power of -2 and then adding 3. Take a minute, pause your video, see if you can fill in this table of values, and then turn it back on. You should get 19. That's not fitting on my graph. Substitute in -1. Should get 7. So I'm going to guesstimate that one. Substitute in 0, 4, 1, 3.25, 2, 3.0625, 3 point, and then a little bit more. And I could keep going here, but do you notice I kind of hit 4, then 3 something smaller? I bet if I went out, I'd get 3 something even smaller, which kind of fits my theory of move it up 3. So instead of my horizontal asymptote being at 0, I'm going to move it up 1, 2, 3. And then this graph is going to come down and approach 3. It's going to get really, really, really close to 3. Domain, still all real numbers. Range, this time I'm kind of sitting at 3 and getting bigger. Y is greater than 3.